Obed, I can hear you. Yes, Obed, what you're saying?
Nothing, sir. I just
Okay. Okay. So, good morning to all. Very good morning, guys. Very good morning. Let me put myself to spot now. Yeah, perfect. A very good morning, guys. How are you all? Doing good? Doing good? Yes or no? Agatha, we have two Agathas. We have one David, Abraham, and Vesta joining. Can you hear me? Agatha, Rina, David.
Yes, sir.
Very good morning, guys. Very good morning. Okay, so we'll start our class. And before starting the class, you guys have to turn on your camera. Okay, please turn on your camera. Good morning. Good morning. So, Reena, we did some of the like this in this maths. We did, I guess, 3/4. Okay. You know linear equation? Something about linear equation? Linear equation is the DOPS one. So we did solving the linear equation in two variable by two methods. Okay. But today we'll do the word problem. So it might be little bit you may think that you're off topic, but like uh, you can go and watch out the classes. Like I will send you the channel link so you can check the videos if you have time, and then you can get used to it. Okay. Okay. Now everyone turn on your camera, please. We'll start our class. We are not now. We'll not wait for anything. Where my specs? Yeah. So what we were doing? We were doing some
Sir,
questions. Yes.
did you check the homework?
No, no, no. I forgot. Sorry, 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 sorry. I'll check it after the class. After the class, I will check it. I'm so sorry. I forgot. Okay, so what we were doing? We were doing chapter number 5. Okay, now we'll jump to the word problem questions. Okay, now we'll jump to the word problem question. So we'll do some of the word problem question, and I gave you the keywords also. Yes, Agatha, can you repeat the keywords which I gave in the word problem?
For subtraction test, like lesser, if
Hmm.
there's lesser difference,
Hmm.
left,
Hmm.
mm, minimum,
Hmm.
and all what else is there? And all of that. It is subtraction. In addition, if there is add, yeah, also subtraction, there's also
Okay.
subtract.
More
And yeah, in
difference
addition,
is
there's
also
more
there.
than what?
Difference. If difference is also there.
I said that.
Yeah. Okay, Susan. Okay. Perfect. Then
Now, in addition, if there's more than,
more
add,
than
total,
and
find
uh
total, maximum, it's addition.
yeah. So basically, these are the some keywords. If it is there in the word problem, so simply we have to use these operations. For example, if it is written in the question, 4 more than the x. Okay. Now I gave the keyword of more than as a addition sign, plus sign. Okay. So 4 more than x, what it will become? It will become 4 more than means plus x. So it will become 4 plus x. So we are able to make the equation out of the word problem by these keywords. Are you getting this? Say yes or no. Abraham, David, Obed, turn on your camera, please. Are you getting this? No? You have any doubt? Okay. So today we'll do some questions based on this. Okay, if you have copy, then write it down these questions. First, we will understand it, and then I'll give you time to write it down. Now, what is this question? Abraham, can you read this? Abraham, can you read this question, please?
Yeah, yes, sir.
Can you read this question?
The perimeter of a rectangular garden is 20 meters and the length is 4 meters more than the breadth. Find the length and breadth of the garden.
So first of all, what is given in this question? The perimeter. Perimeter of a rectangular garden is given. So I will write it down there like this. Perimeter of rectangular garden. So perimeter of rectangular garden is given, which is 20 meter. Okay. Is there any problem in that? Like the perimeter is given, which is 20 meter. Now, what is given? If length is 4 more than breadth, length is means equals to. Is means nothing else, but it is means equals to. Okay. So we don't know the length and we don't know the breadth. So can I take length as L and breadth as B? Because it's a variable. So take length as L and breadth as B. Now what is given? If the length is, now length means L, is means equals to, 4 is 4. Now what is the meaning of more than? More than means plus and breadth is B. We got this equation. Are you getting this? Say yes or no. No? Obed, David, Abraham? Huh? Now it is given the perimeter of rectangular garden. Now perimeter. What is the formula for the perimeter of rectangle? Like if I will write here, perimeter. So what is the formula for the perimeter? Anybody knows? Can unmute and say. Very good. 2 into L plus B. Now what is the now it is given the perimeter is 20. So can I write here as 20? 2 into. Now value of L is 4 plus B. So instead of L, can I write 4 plus B here? And then plus B is already there. Are you getting this? So say yes or no. Reena didn't understand anything. Ask me, Reena. I just substitute the value of the variable. Did you have any doubt?
No, sir, I understand it.
Pakka? Okay. So, Agatha, you got it, beta? No. Agatha, ask me. Got it? Okay.
Yes,
Now
I
this
got it.
2, yeah. So now it will become 20 is equals to 2 into 4 plus. Now B plus B. So 1 and 1. It will become 2B. Abraham, did you understand? Say yes or no. Abraham, are you there with me? Did you understand this thing? How it become B plus B is equals to 2B?
Yes, I think so.
Yeah. So basically the B plus B is become 2B. Now this 2 will multiply with both the terms. So it will become like this. It will become 20 is equals to 8 plus 4B. Okay. No, how it become 20? Now 2 will multiply with this 4 become 8 plus 4B. Now this 8 will go that side, so it will become 20 minus 8 is equals to 4B. 12 is equals to 4B. And this is multiplied, it will go and it will divide there. So it will become B. So I got the value of B is 3. Did you understand? The value of B is 3. Now I will put this B value into this so that I can get the L also. It becomes 4 plus 3. So L is 7.
So how do you get the value as B3?
How I got the value of B as 3? So basically, when I substitute the value of L as 4 plus B, I got 4 plus 2B.
Yes.
Yes or no? Now
Yes,
this
sir.
2 will multiply with both the terms. So it will become 8 and 2B will become 4B.
Okay.
Hmm? Now 8 will go that side become minus. So 20 minus 8 is 12. So I wrote 12 equals to 4B.
Yes, sir.
Then
Yes,
4
sir.
will go and to multiply. Divide, sorry. 4 will go that side, it will divide. So it becomes 12 by 4 is equals to B and B is equals to 3.
Yes, sir. Got it.
Write it down, everyone write it down. Abraham, write it down, beta. Quickly write it down. Any doubt? Please ask me. David, doubt or no? No. Good. Ibrahim, you wrote this?
So 1 minute.
Yes, Ibrahim. You saying something?
No, sir.
Okay. I hope you're writing everything, na? Notes are completed. Okay. Miracle didn't join, and one more person didn't join. Who is that one person?
Naintara.
Nayantara. Okay. Because Nayantara is exam. Okay. Now, who will read this? David will read this. David, read this quickly.
Asha is 5 years older than Robert. 5 years ago, Asha was twice as old as Robert was then. Find the percentages.
Now we'll make this equation. Okay, what the question is saying that Asha is 5 year old as than Robert. Means older than means if to my age is 15, then Asha age will be 20, like 5 years older. Are you getting this? If Abraham age is 12, then what is the 5 years older than a person? It will become 17. Yes or no? Did you understand, everyone? Say yes or no. Abraham, you got it, beta? So we don't have the age of, first of all, whenever you are doing these types of question, you have to find what is unknown. What is unknown? So Asha's age is unknown and Robert age is unknown. Are you getting this? No. Hmm?
Sir,
So yes,
can
yes, Solo.
I
Yes.
answer?
Sorry, say it again.
Can I tell the answer?
Of this question.
Can't we isn't it just like the Asha's age is 15 and Robert's age is 10?
We'll check it out. We'll check it out. But I guess we'll check it out. We'll check it out. Okay, so maybe you guys can get the answer directly, but directly if you will write here Asha is 15 and Robert is 10, then they will not give you the full mark. So we have to do the step by step. Okay, so we'll check it out. We'll check it out that Obid answer is correct or not. So let Asha's age be X and Robert age be Y. So Abraham, like I'm underlining this. From this, what equation you can make? Can you see this? Abraham, can you
Yes.
see this?
Yes.
I underline this. So from this, what equation you can make?
So we could say Asha X plus 5
Okay.
The x minus 5 is equal to y.
Okay. But yeah, that is correct equation.
And then
Okay.
what I
No
can do
problem in
is
that.
I can take Asha was 2, twice as old as Robert, and then I could say 2y,
Hmm.
2x.
Yeah.
So I'm not able to do this.
Okay. Okay. So basically, Abraham says that x minus 5 is equals to y. That is correct. But it is not according to the word.
Can I do 5
Okay.
plus?
Yeah. It is not according to the word. Okay. What I'm trying to say, Abraham. So we'll do what step by step. So unmute your mic, please. Now, Asha. What is Asha? Asha is x. Okay. So I will write here is x. And what is? What like I gave the keyword. When is will come, what we have to write? Unmute your mic and say, Abraham. Yeah, Nira. Anybody can say.
Is equal to.
Equals to. So is came, I will write equals to. And 5 came, I will write 5. I'm now older than Robert, means obviously it will be plus, no? If I am older than somebody, so it will be plus my age, no? So plus 1. So Abraham says x minus 5 is equals to y. That is also correct. Why? Because the plus 5 will go that side, become minus 5. रखो बाद में खा लो अभी कैसे होगा So Abraham says x minus 5 is equals to y. That is also correct, but it was not according to the equation. Okay, Abraham, got it, beta? Yeah. Now, now we'll do the second equation. So David will tell me this equation. How will you make the sorry this word problem? How will you make the equation?
Uh, so x minus 5 is equal to 2y.
Okay. Okay. Now David did some mistake. First of all, why you did x minus 5, David? Like why you did? What's the reason of
X
x
is
minus 5?
Asha's X is Asha's current age or
Current age.
current age. So I did x minus 5 because it was 5 years ago.
It is 5 years ago. Yeah, that is correct. So, like for example, right now I'm 26 years old, and David, what's your age? 16
15,
or 14, 15.
15,
Okay, so
15.
my age is 26 years old, and David's age is 16 years old. Now, 5 years old, if I will talk about 5 years old, so my age will become 21. David, your age will be 16 or it will be 11? It will be 10. It will be 10 now. Because if I am subtracting my age, like in 2021, my age is 21 and David age is 10. Are you getting this? So it means that 5 years ago means the Asha age will also be subtracted by 5 and the Robert age will also be subtracted by 5. Are you getting this? So it's gonna be look like this. I will write like this. 5 years ago. So if I will talk about 5 years ago, what does this mean? So Asha's age will be 5 years ago. What will be the Asha age? Anybody can unmute and say, what will be the Asha age? It will
X
be
minus 5.
x minus 5. Very good. And what will be the Robert age? Yes.
Can we make like Asha's age 2y?
No,
5 years
right
ago.
now, no. Right now, we are just making 5 years ago Pala part. Okay. We are not doing afterward Pala part. We are just doing 5 years ago. And 5 years ago, we got that Asha age is x minus 5 and Robert age is y minus 5. Got it? Now we'll read the next part. Now we'll read the next part. Asha. What is Asha? X minus 5. So I will write here like this. X minus 5. Now was is also the keyword which I gave, which is meaning as equals to, which means that equals to. I will write equals to. Twice. Twice means to multiply. Twice as old as Robert was then. So twice as old as Robert was then. Ask me.
So shouldn't it 2y minus 5?
No. What is saying? It was not saying that as old as Robert right now. It's saying was then. Was then it was 5 minus 5. No? Y minus 5. No? Are you getting this, Agatha, Abraham? Abraham, you got it? No. Abraham, say yes or no? Yeah. Okay. So, yeah. So now we have to solve this. So what I will do? I will multiply this and this. So it will become x minus 5 is equals to 2y minus 10. And then further, if I will solve it, so it will become x is equals to 2y minus 10 plus 5. So x is equals to, what it will become? X is equals to 2y minus 5. Okay. And if I will send everything to the left side, it will become x minus 2y plus 5 is equals to 0. And then I will put the value of x, which is 5 minus y. So 5 minus y, I will substitute the value of x into this. Minus 2y plus 5 is equals to 0. So it will become minus, like if I will solve this, I will get answer as minus y. Minus y plus 10 is equals to 0. Minus y is equals to minus 10. This and this will cut, so y is equals to 10. I got the value of y as 10. And then if I will put the value of y into this, then I will get x is equals to 5 plus 10. So x is equals to 15. So I got x as 15 and y as 10. Anybody has any doubt? Please ask me. Obed, Agatha, any doubt? No? Write it down then. Reena, you have any doubt, beta?
No.
None. Quickly write it down. Abraham, write it down, beta. Quickly. Yes, beta. Who's saying something?
Yeah, sir. So I understood, sir. So basically, so we are substituting the equation in the equation to make sure there's only y terms, right?
Yeah.
Okay,
We are
thank
just
you.
substituting it so that we can get the one of the value. Then we are substituting another equation and we get the another value also. Simple as that. Quickly write it down. And now I will do this next question, and it is one of the important question. Okay, so please, you have to pay attention. You don't have to write it. Okay, Agatha. Agatha, I can see your two devices. Is there any glitch?
When I tried to join in, there was some internet connection, so again tried to join in, and I guess that's what happened.
Okay. Everyone got this? Say yes or no. Quickly write it down. I'm giving you 2 minutes. Yeah. Done? Done writing? Now we'll do the next question. Okay. So now we'll do this question. This is one of the important question. So you have to pay attention. Then only you will get it. Now, this question says that, everyone please see on the board. Two places A and B are 100 kilometers apart. Means they are 100 kilometer apart. One car starts from A, another car starts from B. So we'll make this diagram. So for example, these are the 2 points A and B, which is 100 kilometer apart from each other. It is 100 kilometer apart from each other. And I will make 2 cars also. Don't laugh on my drawing because I am D grade student in the drawing. Okay. So these are the 2 cars which is on A point and which is on the B point. Okay. Now, if they travel in a same direction, they will meet after 5 hours, which means that, for example, car A moves towards right side and car B also move towards the right side. Okay. So if they are traveling in the same direction, they will meet at another point. For example, this is the another point C. They are meeting at C point. Are you getting this? Still here any problem? Hmm? So, for example, car A traveled till C and car B also travel at C and they met. Obviously, so I will ask this simple question: which will have more speed, car A or car B?
Car B.
Car B. Car B has more speed. Okay. Anybody else? Why Rina car B will have more speed?
Because it's closer to cars. I mean, closer to C.
Closer to C. So if car B is closer to C and car A is far away from C, so which car cover more distance? Car A or
Car
car
A.
C?
A.
Car A. And they are meeting, they both are meeting at 5 hours. It means that car A has to increase the speed to cover up the extra distance. Na?
Ah.
So which will have more speed, car A or car B?
A.
A. Okay. So car A will have obviously more speed. That is why it has to cover 100 kilometer that part. Okay. To meet at C point. Are you getting this? Yes or no? Yeah. So we don't know the speed. Like we have to find the speed of car A. Sorry, we have to find the speed of 2 cars. So I will take that. Let the let the speed of car A be x and the speed of car B be y. Are you getting this? Say yes or no. Still any problem, guys? Abraham, Agatha, David? No? Hmm? Now, obviously, if I will write it like this, distance covered by car A minus distance covered by car B is equals to what is the distance? Okay, Abraham will tell me the answer. Abraham, for example, car A is covering this much distance and car B is covering this much distance. If I will subtract both of them, what will I get? Tell me, Abraham.
Can you just repeat?
I will repeat it again. For example, car A is covering this much distance to meet at C. And car B is covering this much distance
You will
to
get the
meet at
distance
C.
the distance between the 2 cars.
Yeah, what is that? Tell me the value. If I will subtract these, then what will I get? I will
100
get this
kilometers.
distance. Yes, I will get 100 kilometers. Are you getting this? Yes or no? Now, car A takes how much time to reach at C? 5 hours because they start simultaneously. So, car A took 5 hours to reach at C. And car B took how much time? Same 5 hours. Are you getting this? Yes or no? Everyone got this? Hmm? Now, what is the formula for the distance? What is the formula for the distance? Anybody knows? Like speed is equals to distance upon time. So what is the formula for distance? Distance formula is speed into time. Got it? Yes or no? Now, distance covered by car A. How much car A distance covered? So what is the speed of car? Speed of car is x and it took 5 hours to reach. So what will the distance covered? Because the formula is speed into time, so it becomes 5x. Now you got it. Obey. You got it how it become 5x. X is the speed of the car, 5 is the time. And because distance means speed into time, speed is x, time is 5x. Got it? Say yes or no? Hmm? And now, what will the distance covered by car be? What will the distance covered by car be? Will you tell me anybody? Huh? What will be the distance covered by car be? Anybody can unmute and say.
5y.
Like, yes, 5y. Very good. Why 5y? Because the time is 5 hours and the speed of is y, so it becomes 5y. So 5y is equals to 100. So I got one equation 5x minus 5y is equals to 100. Are you getting this? Yes or no? Everyone got it? Abraham, David, got it? Hmm? Now, now we have completed this part. Now we will read the next part. If they travels towards each other, they meet in 1 hour. If they travel towards each other. Now, for example, what does this mean? This means that car A is moving. I will make it with different pen. Car A is moving and car B is moving like this. And they are meeting here, for example, car D. So this is this one and this one. Okay, so they meet in 1 hour. So for example, car A also take 1 hour and car B also take 1 hour to reach at this point, B point. Okay, now so this is distance. So this is distance covered by car A and this is distance covered by car B. If I will add them, what will I get? Right? Hmm. Your voice is very low, beta. I can't hear you. Devin, you're saying something? We'll check it out. Okay, so if they move towards each other, so like Veena, can you tell me, like distance covered by car A and distance covered by car B, if I will add that, what will I get?
Uh,
Like distance covered by car A plus distance covered by car B when they are moving towards each other, what will I get?
Not sure.
Okay, like how much distance cover? Huh?
Isn't like the total distance 100 kilometers?
Yeah, see,
So
like
the
this is the car
total
A. Yeah, this is car A. It meet at this point B. This is car B. It meet on this point. So if you will add it, what will you get? You will get 100. Are you getting this? No. Hmm? Ask me, ask me. Got it? So it will become how much? This will also become 100. Now what is distance cover? Distance covered by car is 1x because 1 is the time and x is the speed of a car minus sorry, plus 1y is equals to 100. So I got x plus y is equals to 100. You got it. Say yes or no. Please ask me if you have any doubt till here. I'm waiting for you guys.
No doubt.
No doubt. So x will become 100 minus y, and then I will substitute this into this equation. So it will become 5 into 100 minus y minus 5y is equals to 100. So this will multiply with this. It will become 500 minus 5y minus 5y is equals to 100. 500 minus 10y, because they are the same sign, so I have to add it, is equals to 100 minus 10y is equals to 100 minus 500. So minus 10y is equals to minus 400. This and this will cut. Y is equals to 400 by 10. If I will cut it, I got 40. And if I will put into this, I will get x as 100 minus 40, x as 60. Means the speed of car A is 60 kilometer and the speed of car B is 40 kilometer. This is the answer. Abraham, Obed, Agatha, got it? Say yes or no.
Yes, sir.
Yes, write it down quickly. Quickly write it down. This is the important question. Very important question. Now try Joshua. You
No, sir.
may
It's
be
still
getting.
same pick.
Now try one more time.
No, sir.
You're not following me.
Johnny multiple times, sir.
No,
And
you're following me. Like you
I
may
was
get
following. I was following you, but then this happened, sir.
Why this is
Also, one more thing, sir.
Joshua is there. Okay. Agatha, please put this message in the group. This is the homework. I'll write the page number also. Page number is 164. This is the homework. So you guys have 2 minutes break. You guys have 2 minutes break. Come back. We'll start our science class. Till then, bye, Obed.
I bet.
Bye.
Come back in 2 minutes. Maybe you can try it again, Joshua. It's like I think it's your glitch. Or if there is any option of update, so update it.
No, it just says failed wait till load canvas kit, load failed, then I'll show the fun stuff.
How it can be possible?
I'll rejoin, sir. I'll try to.
Or update it from the Apple Store.
Okay, sir. I think it's not working, sir. I'll be back in a few minutes.
Okay, guys, come back. Come back quickly, come back. We'll start our class. So we were doing force, and yesterday we learned about the two types of forces. First is balanced force, and the second is unbalanced force. Yes. Chapter number 10. Can you see the PDF? Is it visible? PDF is visible to you? Can you see it?
It's loading.
Now maybe you are able to see, no?
Yeah.
Okay. So can you see the?
Sir, I
Yeah.
can't see it.
You can't see it.
Yeah.
Will you follow my view? Yeah. Why is it happening? Can you see it now?
No.
Now?
No.
What is showing? Nothing.
Nothing.
Now can you see it?
No.
Why? Everyone has same problem.
No, sir, I can see PDF.
You can see the PDF. Okay, I will image the pages. Maybe. Can you see the page now, Reena?
No.
Okay, we'll remove this. Okay, directly show the picture. Now, can you see the image? I mean, the PDF, which is in front of
Yes.
you?
Yes, sir.
Okay. Now, everyone turn on your camera, please. Come back, come back. Yeah. So we learned yesterday about the balanced force and unbalanced force. So you can see this, that this is the balanced force in which the tug of war, two children are there, they are playing tug of war and they are pulling with the force. And the opponent is also pulling with the same force. And because of that, the rope is not moving. It is becomes still. Okay, so this is called as balance force. We are putting the force, but it is not moving. For example, this is box in front of me. Can you see this box? Okay, so if I will push it like this, like for example, if I will, okay, I have to remove my blur effect. No. So, for example, this is a box in front of me. If I will push it like this, so box is moving. So, is this a balanced force or unbalanced force? It's an unbalanced force because unbalanced force makes the box to move. But if I will do it like this, that if I am pushing with both the side, so like I'm putting a force here also and I'm putting a force here also. So it means that the box will not move because the both side we are getting force. I'm putting the force, but it is not moving. This is called as balanced force. Now today we're gonna learn about the inertia. Okay. Now what do you mean by inertia? Okay. Inertia we can understand it like this. If I will ask you guys that which one is easy to move, a box like this or a big Almira?
Box.
Box.
Yeah,
Why? Why? Why it is easy to move a box rather
because
than a big Almira? Yeah.
because the weight of the box is less and the Almara's weight is more.
So it means that the box is less and the Almira is more. Okay, so it means that if you need more force, if more mass is there, are you getting this? Huh? If you need more force to move a more mass object. Huh? So this is called as inertia. Inertia is the property of an object which have mass. Are you getting this? No, you didn't get it. Okay, so for example, why the big Almira is not moving when you give the small force? For example, I will take one example. Here's the example. For example, this is the box. Okay, this is the box. Can you see it? Is it visible?
Yep. So
So I am taking my small finger and I am putting a force in it. It's not moving. It's not moving. It's not moving. It's not moving. But now when I took two finger and when I put a force, okay, now the force is more. And if the force of my force is if it is more than the inertia of that object, the object will move. Are you getting this? No. Means your force or outer or the external force should be more than the inertia of the object, then only the object will move. Hmm? If your force is less than the inertia of that object, then object will not move. Object will remain at the same place. Like one example I will take. For example, we are in the car and the car is at rest. Now, if the car will start to move in forward direction, then what will happen? Your body will go in a backward direction. Hmm? If car stops suddenly, then what will happen? Your body will stop like this. If car will go in the left direction, what will happen? Your body will go in left direction. And if car will go in right direction, your body will go in the right direction. So our body, the upper body part, it always work as a inertia. Why? You know why? Like if car stops suddenly, our lower body is contact with the car. Yes, our lower body is contact with the car. But the upper body is in the air, having its own inertia. Uh, suddenly it stop. Suddenly stop. So our body will remain. It will come in a forward direction because the car is suddenly stopped. Because our body has an inertia. That is why we wear seat belts so that it won't give a injury to us. Are you getting this? No.
yes, sir.
Okay. Did you saw one video in which like a woman just like beating the big carpet? What will happen in that case? If you will beat a big carpet with a bat, what will happen? The dust
Dust
will,
comes.
yeah, dust come. Why the dust will come? Because when you are putting a force on it, the carpet moves suddenly. Dust remain in that inertia, and because of that, the dust will come out. Are you getting this? No. Hmm? If you will suddenly, like if you will do like slowly, slowly with lovely, lovely. Oh my God, my carpet. Oh no, 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 no. The dust will not come. Hmm? You have to hit hard, and when you will hit hard, suddenly like this, the carpet will move back. And when the carpet will move back, the dust will be at the same place because of the inertia, and the dust will come out. Are you getting this? Inertia? Abraham? Rina? Nidhi? Got it? Hmm? So now we'll learn about the inertia. Abraham, you have any doubt? You were saying you were about to say something.
No, sir, I don't have any doubt.
Okay, so we'll read it. So who will read it? Joshua will read. Joshua, can you read this?
You would have seen that whenever we shake the branches of a tree vigorously, the leaves and fruits get detached, sorry. Similarly, when you beat a carpet with a stick, you will see that dust particles get detached from the carpet. Do you know why? The answer to all the answer to all such questions is inertia. What is inertia? We can understand the property of inertia by doing a simple activity.
Yeah, read the activity also.
Take a smooth sheet of paper, 30 centimeters by 8 centimeters, and place it on a table with some part of it coming out of the edge of the table. Now place a glass half filled with water on the paper. Remove the paper with a jerk. Figure 10.4. What do you observe? You will find that the glass remains in its position. The inertia of the glass prevents it from moving with the paper.
Correct. So you can see this right now. The inertia of the glass is basically the person who just put we saw many videos in which they take this tablecloth and they do it like this. So when they do it suddenly, the everything remains at the same place because of the inertia. Are you getting this? No. Hmm? Okay, I'll show you one video also to get more thing about the inertia. Just give me a second.
Uh, inertia has
Yes, Nidhi, there is sound is also there. I can't hear you. Say it again loudly.
yeah, inertia, like when we do something like the activity, because why is inertia working? Because the object's mass is higher or lower.
The object wants to be remain like it always resists the motion and wants to be remain. Like for
Okay.
example, if it is at rest position, it always wants to resist the motion to become at a rest. It's become like alsi like me. Okay, it is very alsi means lethargic like me.
Lazy.
Okay, if it is at rest, it remains at rest.
Okay.
Okay, just um, I'm just searching for one video. Where is that for? Oh, okay, I got it. I'll. Oh, what does that mean? Yeah. So you can see that right now the object is basically at rest. The dust particle which is on the racket, can you see this? No, is it not visible? Is it visible?
Yes, sir.
Hmm? So you can see here the dust particle which is on the racket right now, it has rest position. Rest position. And because it is at rest position, so dust particle wants to be at rest. So when sudden motion will come, they will resist the motion. And because of that motion, we will see what will happen. Can you see this? Can you see this? Suddenly, the racket goes down, and because of that, we can see that these are the dust particle which remain at the rest, and the property behind that is inertia. So because of inertia, they remain at rest and they don't want to move. Okay, so that is why they came out. In the same way, the dust particle from carpet, or in the same way, our body is also moving. These all will have same phenomenon of inertia. Got it? Everyone got this inertia topic? No.
Yes, sir.
Yes, sir. Yes, sir.
David, Abraham, got it?
Yes, sir.
Okay. So we'll now read this. We'll come back. Just give me a second. Can you see the PDF?
Yes, sir.
Yes, sir.
Okay. So now we'll read this. So please, Joshua, read this.
Thus, we can say that the inertia is the tendency of objects to stay at rest or keep moving with the same velocity. You can find out. You
Yeah,
can
read it.
find. You can find out more examples of inertia from your daily life. In fact, it is the inertia due to which a sprinter keeps running for some time, even across the finish line. Similarly, you will notice that it is
Underline
difficult.
this. Underline this. This is a very important line. In fact, just underline this. Where is that? In fact, the inertia due to which a sprinter keeps running times even crossing the finish line. They can ask you why. Why? So, for example, a sprinter runs like Hussein Bolt runs very fast. No, so he started from the start rate line. Okay, and then he's running, and the cross line came. So he can't stop suddenly. If he will stop suddenly, then what will happen? Because the above body is it is in motion. The above body is in motion. So when he stops suddenly, the lower body stops, but the above body is in inertia, is in motion. It will move forward and he can fall.
And
Are you getting this?
you can break his ankles.
Yeah. It's only happen in cartoon in which I don't know that you guys saw that Roadrunner or not. Roadrunner is a cartoon episode. He used to run fastly and then he stopped, but it only happens in cartoon, not in real life. In real life, if the person stops suddenly running and stops suddenly, then you know what will happen? Because his upper body is in inertia, he will have a teeth surgery. Are you getting this? No.
Yes, sir. Yes, sir.
Okay. So read it from here, Joshua. Similarly,
Similarly, you will notice that it is difficult to take the tomato sauce from a bottle just by inverting it. However, it is easy to take out the sauce from a bottle by giving it a sudden jerk, by moving the bottle in a downward direction when the sauce comes in motion. When the bottle
yeah.
stops suddenly, the sauce remains in motion due to the inertia of motion, and due to the inertia of motion, it comes out of the bottle.
So, like, if sauce bottle is there, what we used to do? We used to do like the tack, tack, tack. Okay. So, because it is so that the sauce will come in motion, and when the sauce will come in motion, it will automatically it will come down. But if you will just do like this, the sauce will He's very like a snail. Slowly, is coming because of gravity. But when you have to put a jerk on it, then it will come suddenly on the mouth and it will fall down. Got it? Say yes or no. Reena, you got it, beta? Now, what is the thing is what is the relationship between the mass and inertia? Mass is basically right now it's basically the weight that we are talking about. Okay, so mass and inertia. So it is basically this sign is called as the sign of this sign is called as the sign of proportional. We can say directly proportional. Directly proportional. Okay. Directly proportional means that if you will increase the mass, the inertia of that particle will be more. For example, we'll take one example that Joshua was like he's pushing a small toy car. So from small toy car, because the inertia is less, he can use only one hand or more only one finger to push it. Okay. Now the car is becoming a Alto car or the Fronx car or the Toyota car, any car, big car. Hmm? Can he push with the one hand, one finger, one hand, two finger, two hand? Even he will call that, sir, you told me to push the car. You also come and join me and push the car. So because why? Because the Toyota car is very heavy. Like it's a great mass, like great mass than the toy car. So that needs a lots of like you force. So if the mass is more, if mass is more, then inertia is more. For example, if a toy car is coming towards the Joshua, so Joshua can simply put one hand, okay, and stop that car. Okay. But if a big car is coming, can Joshua do like this? If he will do like this, lunch with Jesus. Got it? Yes? So, yeah.
Yes,
So,
sir.
this is basically if mass is more than more inertia. Yes, Niti?
So what is density? Density.
Huh? Say loudly. I mean, disturbance is there. Yeah. Read it again.
Yeah, mass. You wrote mass D inertia. What is
Yeah.
T?
Yeah. This is called as directly proportional. This is called as what? This is called as directly proportional. What is the meaning of directly proportional? Like if you will increase the mass, if you will increase the mass, then inertia will also increases. This is the meaning of it.
It's not like when mass is increased, the inertia decreases.
No, no, no. That is direct. That is indirectly proportional. This is directly proportional.
Okay.
Okay. Everyone got it? Reena got it? Abraham, turn on your camera. Did you understand, everyone? Yes, yes, Agatha.
So inertia is basically the tendency of an object to actually be lazy to move or change its position of rest or motion.
Yeah. So inertia is basically if object is in motion. If object is in motion, like we took one example, just previous one, like a toy car, it is moving. It is moving now. So toy car, because less mass is there, Joshua can just put one hand and it will stop. Now, if a big car is coming, can Joshua stop it with one hand? No, no. So basically, inertia is not only about an object which is at rest to move that to resist it. That is called inertia. No. If object is moving also to stop it. If object is continuously moving to stop it. Okay. That is also in that case inertia is working. You know why? Is it easy to stop a cycle or is it easy to stop a big truck with the same speed? With the cycle, no?
Yeah.
Cycle, because cycle has less mass means less inertia, and truck has big truck means more mass means more inertia, and more chances to have a lunch with Jesus. So basically, if you want to stop a cycle, so it's also moving. So basically, if I will talk about this, inertia is basically three types. You can write it down if you want to write it down. If you are writing it, inertia are three types. First is inertia of rest. Second one is inertia of motion, and the third one is inertia of direction. So these are the three ways of inertias are there: inertia of rest, inertia of motion, and inertia of direction. Now, what is inertia of rest? Inertia of rest means an object is at rest and suddenly the motion came. To resist it, the object wants to be remain at rest. Like beating a carpet with a dust particle. Dust particle and carpet was at rest. Suddenly the motion came, and when the motion came, the dust particle remained at rest. It is the inertia of rest. Are you getting this? Hmm? Second, inertia of motion. Inertia of motion is object is at motion. Suddenly the thing came to stop it, but the object wants to be remain at motion position. For example, when we are in the car and suddenly the car stops. Car is at motion and suddenly the car stops. When car stops, our upper body part is in motion with the car. But suddenly it stops, it moves towards the forward direction because it's moving. Our body is also moving. It is resisting the stop motion. Are you getting this? Third one, inertia of direction. When you are driving and suddenly Papa took a right turn, then you will say, whoa, and you are also going towards the right direction because your body is in the straight line motion. Okay, but suddenly the direction change, your body, the upper body part is moving in the right direction, like that. So basically, inertia are of three types. First is inertia of rest, second is inertia of motion, and the third part is inertia of direction. Are you getting this? Say yes or no.
Yes, sir.
Okay. Reena, got it? Abraham? Abraham has doubt. Abraham, ask me better.
No, sir, I don't have any doubt.
Very good. You don't have any doubt? Correct. Okay, so we'll read it. So Abraham, can you read this? Inertia and mass.
What's the last type of inertia?
Inertia of direction.
Direction.
Thus, you can say
Sir.
that inertia as the tendency of
Yeah, somebody's saying something. Just give me a
I'm
second.
sorry.
that
Like,
due to
can
inertia,
you
objects offer resistance.
Abraham, just give a second. Yes, Nidhi.
the PDF, can you zoom it a little more?
Zoom it or zoom out?
Zoom it. Zoom it.
Zoom.
It's very like when I am zooming from here, the whole thing is zoomed. Yeah.
Now can you see it?
This is it.
Yes, Abraham. Abraham, read it now. Abraham, read it better.
By
You're
now,
mute.
you have learned that due to inertia, an object offers resistance to change its state of motion. Do all objects have the same inertia? Let us find out. Push an empty box on a smooth surface. Now try to push a box full of books on the same surface. What do you find? It is easier to push an empty box than a full box of books. Now suppose you are asked to stop a table tennis ball and a cricket ball moving with the same velocity. Which ball are you supposed to apply more force to stop? You will find that the cricket ball requires more force to stop as compared to the table tennis ball. Thus, all objects do not resist a change in their state of motion equal. Massive objects resist more than lighter ones. What do you conclude from these observations? We can say that mass is a measure of inertia.
Yeah. So mass is the measure of the inertia. This line is very, very important. Okay. This line is very important. You can say that the mass is the measure of the inertia. If more mass is there, more inertia is there. Okay. Got it? Abraham got it? No.
Yes, sir, I got it.
Yeah. Now we'll read the Newton's first law, and it's very easy law. Yeah, we'll read it. Yes, Abraham, continue with the reading.
We have learned about objects offer resistance and change in the state of motion. This was studied by Newton in detail and he presented his findings in the form of three.
Yeah. Forward 3. This one.
Three fundamental laws that govern the motion of objects. Newton's first law of motion is stated as follows. Every body continues in the state of rest.
Underline this, okay? Read it again. Read it again, Abraham.
Every
Everybody.
body continues in a state of rest or uniform motion in a straight line until it is compelled by some unbalanced force to change its straight line.
Okay. So what this law says, Newton's first law says that until and unless, you have to learn this like this. Okay, I'm making it very easy for you. Until and unless an unbalanced force is not applied on a body, the object will not move if it has rest. If it is moving, it will not stop. This is the basically Newton's first law. I'm repeating again. Until unless an unbalanced force, an external unbalanced force is not applied on an object, the object will not move if it is at rest. If it is at rest, the object will not, no, if it is at moving, the object will not become rest. This is basically the meaning. For example, okay, listen it. For example, the object is at rest right now. Can you see this? My box. Now, if I am putting the force, so I am putting a force. So my force should be more than the inertia. My force should be more than the inertia. If my force is more than the inertia, then only the object will move. So I am putting an unbalanced force. And because of that unbalanced force, the object is moving. This is called as Newton's first law. Are you getting this? No. So you want to put a unbalanced force to make object. If object is at rest, to stop it. If object is in motion, to stop it, and if object is at rest, to move it. Simple as that. Are you getting this? Yes. Now doubts.
No, sir. Not able to.
Yeah.
I'm not able to understand this.
The main concept behind it is only simple like that. That you need an force, external force, to move an object if it is at rest. And that force should be greater than the inertia of the object.
Okay.
For example, to move a almirah, you need a greater force. You can't force with the one pinky finger. You need a greater force. And because you need a greater force, then only the almirah will move. So that is the external force which makes the object which is at motion to move. Now, for example, we are at a bicycle. Okay, we applied the brakes. So if you will apply little brake, the will cycle stop suddenly? No. You need a great force of brake so that the cycle will stop suddenly. So you are putting an external force, and because of that, the cycle is moving. Cycle is stopping. So until and unless, okay, keep this in mind. Until and unless an unbalanced force is not applied on an object, if it is at rest, it will not move. If an object is in motion, then object will not stop. Simple as that. If you apply a great external force, the object will move. If you apply the great external force, the object will stop. Are you getting this? David has doubt. Yes, David.
No, sir. No doubt.
No doubt? Okay. Okay. Reena, can you read from here, please? Reena, can you hear me?
Yes, sir.
Can you read it?
Uh,
From here, can you see this?
yeah. Newton's first law of motion tells us that all bodies resist a change in their state of motion. We know that this property of bodies is called inertia. That is
Now,
why
if they will ask you, what do you mean by inertia? So you have to write whole thing. Newton's first law, motion of tells that the body resists their change in motion. We know that this property is called as inertia. Yeah. Read it
That
next.
is that is why Newton's first law of motion is also known as the law of inertia.
Law of inertia. Why? Because you need an unbalanced force to bring an object into the motion. An unbalanced force. Okay. Yeah, we'll complete it and then we'll take doubts. Yes.
First law of motion has many applications in our daily life. Why do the passengers standing in a bus fall in backward direction when the stationary bus begins to move suddenly? Figure 10.5.
Hmm. So you can see that person, he is just standing in normal direction. But suddenly the bus started, the body, the lower body is in the contact with bus, there is no problem. But the upper body is in air. And because of that, it is not in direct contact. And the bus moves suddenly. So it goes in a backward direction like this. Yes, yes, Nidhi. Tell me about beta.
Yeah, the one like Newton's first law of motion, that one. Is this the definition of inertia or?
Yeah, this is the definition of inertia. Okay, so this is what we learned in the first thing. So if I will read it quickly, this mass. Oh, wait, sorry. Yeah, I will read it quickly. So this observation can be explained on the base of first law of motion. So we have this reason also. Please, you have underlined this. The feet of the passenger are in contact with bus. When the bus starts suddenly, the wheel starts moving with the bus, but the upper body part tries to remain as such because of the inertia. Tends to fall in a backward direction. Okay, and what will happen if a bus stops suddenly? In this case, the passenger standing in the bus falls in forward direction. Why? Because the lower body is in contact with the bus. The bus stops suddenly. The lower body also stops suddenly, but the upper body is in air, and it is called as inertia of motion. The body is in motion, and it stops suddenly. It goes in a backward direction, in forward direction. Yes, yes, David.
What if my hands could reach the top of the seat, like of the bus, and the
Hmm.
feet are touching the floor? Would
Hmm.
would anything happen if the bus like suddenly starts moving? Would anything happen? Then like what?
Yeah, so you will resist, like still the body will go in forward direction. Still the body will go in forward direction, but you will not fall. If you're not holding it, so the whole body part is free. And suddenly the bus will stop, you are going in forward direction. But when you will hold this, okay, so the your hand is holding you not to fall in forward direction. It's gonna be look like this. Still the inertia will be there. Got it, David? No. Okay. Everyone got this? Everyone got the inertia, the first law of motion? Anybody has any doubt? Reena has doubt. Yes, Reena. Abraham, doubt? Nidhi, Joshua, any doubt?
No, sir.
No?
Yes.
No. Okay. So we'll end this. I hope you have enjoyed the class and we'll meet tomorrow and we'll do the momentum, which is very interesting topic. So we'll do it. Till then, bye. Have a nice day. Signing off. Taro Shabakhe. Sayonara. Bye bye.
Everyone.
Bye, sir. Thank you, sir.
Thank you.
Bye.
Bye. Thank you. Bye.
Bus?
Thank you. Bye bye.